Hello everyone. Today I will be talking about query auto-completion. So have you ever noticed how Google or YouTube seems to finish a sentence before you even finish typing? Like you start by typing something like best places to visit in, and suddenly you see suggestions like India, Europe, or December. That's the magic of query auto-completion. It's an algorithm that predicts what you're about to search based on millions of past queries, popularity, and even context. So in this presentation, we'll walk you through how query auto-completion works behind the scenes, from data collection to real-time predictions, and how the tree data structure makes it all lightning fast. So query auto-completion is a feature that helps users complete their search queries faster by predicting likely completions as they type. It's widely used in search engines like Google and Bing, e-commerce sites like Amazon and Flipkart, and even social media platforms like YouTube and Twitch. The main goal is simple: reduce typing effort, save time, and improve user experience. But what seems like a small feature actually involves massive data processing, machine learning, and efficient data structures. So every time you perform a search, your query is stored in what we call search logs. These logs form a historical record showing what users have searched for, how often, and when. Over time, these logs help the system identify common patterns like popular phrases, trending searches, and seasonal interests. For example, around December, Christmas gifts and New Year vacation might spike. This information becomes the foundation for predicting future searches. Now, once the data is collected, the system stores it efficiently using a special data structure called a tree, also known as a prefix tree. Each node in a tree represents one character. When we insert words like car, cat, and cart, they share common prefixes, which saves both time and space. So instead of storing each word separately, the tree groups them by sharing beginnings. This allows the system to instantly retrieve all the completions for a given prefix, like everything started with the car. Now, not all completions are equally useful. The system must rank them before showing suggestions. This ranking is based on several factors. Okay, now the factors are frequency, which shows how often a query was searched, recency, how recently it was searched and capturing trends, and context. Sometimes results are personalized depending on user history or location, and then the popularity, which tells how widely a query is searched by all users. In this chart, we can see how popularity often carries the most weight, followed by context and recency. Now, once the system has found and ranked possible completions, it needs to display them instantly. Even as you continue typing, the algorithm continuously updates the list of suggestions as each letter is entered, retrieving matches from the tree and sorting them by frequency, all in a matter of milliseconds. Now, let's visualize how the tree actually works. At the root, we start with an empty node. From there, each branch represents a character. For example, C connects to A, which then leads to R, T, and so on. If the user types CA, the system simply follows that path and retrieves all words branching out from there, such as car, cart, and cat. This makes search suggestions incredibly fast and efficient, even when the database contains millions of entries. The beauty of the trees lie in their efficiency. Searching for all completions of a prefix takes only big O of n time, where n is the length of the prefix, not the number of words in the entire datasets. This is why even large search engines can return instant suggestions. Moreover, trees save memory because they share prefixes and they can store extra information like frequency or timestamps at each node. Now, here's a simple example to make it clearer. Suppose we have three queries: car searched for 100 times, cat searched for 50 times, and cart searched for 40 times. Now, when a user types CA, the system follows that path in the tree, finds all the words that start with CA, and looks up their frequencies. Then it ranks them. So the user sees car, cat, and cart in that order. This process happens instantly every time the user types. Now, coming back to the efficiency of the algorithm, as you can see the graph here, this graph compares the efficiency of tree search versus brute force search. With brute force, the system would need to scan through every single stored item, which becomes extremely slow for large datasets. So, in that contrast, a tree narrows the search space immediately by following the prefix path, leading to a much lower time complexity. In short, trees trade a little extra space for massive speed gains, a perfect balance for real time applications. Now let us look at step-by-step algorithm behind auto-completion. Okay, now when the user enters the prefix, say CA, as we used it already, the algorithm traverses the tree following the prefix. It collects all completions branching from the node. Next, it sorts these words by frequency or relevance. And finally, it returns the top k suggestions, usually the top 3 or 5 results. This entire process repeats dynamically as the user continues typing, making the experience feel almost instantaneous. Isn't that wonderful? Like this whole thing happens in milliseconds. Every time we try to enter a word, by the each character we type, it keeps changing. So, beyond search engines, the same principle of auto completion is used everywhere, from your phone, keyboard predicting words, to IDEs like Visual Studio Code suggesting code completions. It's also used in chatbot, translation tools, and recommendation engines, all thanks to fast prefix based lookup. So, next time you see a search engine finishing your thought, remember it's not guessing, it's learning. Behind every suggestion are millions of data points, structure efficiency using trees, and ranked intelligence using algorithms. Query auto-completion is a perfect example of how smart data structures makes everyday technology feel magical. Thank you for watching.